Hey, so I am currently inside this assignment, the WAMAP vector addition word problems, and I am looking at question number 4. And you can see I already did this one, but I want to show you how to actually do it. So the airplane, it says airplane is flying at an airspeed of 750 kilometers an hour at a direction angle of 90 degrees, but there's a wind blowing at 80 kilometers an hour with a direction angle of 225 degrees. And this airplane, as it turns out, ends up flying off course. Our job is to find out how far off course and how fast does the plane end up going as the resultant. The airplane and the wind combine to give us a resultant vector. What is the magnitude of that? Okay, so apparently this pilot is very stubborn and refuses to steer, and so the airplane goes off course, or the pilot did not pass pre-calculus. And if this is you, I can't actually do anything about situation number one. If you're stubborn, I mean, good luck. But I can teach you about vectors, so let's take care of that. All right, so I got an airplane is going straight up, the direction angle of 90. I know that's straight up on the graph. I got a wind at 225. Um, I knew that 225 is bigger than 180, which would be straight left, and smaller than 270, which is straight down. And so I had to subtract my head. I subtracted 225 minus 180 is 45. Okay, I know what a 45-degree angle looks like. So here's my wind, but I do not want it drawn from the origin. I trying to figure out what direction it's pointing, so it makes it easier for me to draw it here. And then I'm going to move it so I can do vector addition. And now my airplane and my wind pictures line up with my vectors on the graph. So airplane goes up, wind blows back and diagonally down, and then I can draw my resultant. Blam, there it is. So I know that the airplane was trying to go straight up, and instead it got blown off course. And my job is to find, is our job is to find out how far. So we need to get the components, right? So the first thing I had to do was get the airplane. That one I didn't have to do any work because it's going straight up. So the components for the airplane 0 and 750. For the wind, I had to calculate. Took the magnitude of 80 times the cosine of 225. That gives me the x component. 80 times sine of 225 give me the y component. So negative 57.50, sorry, negative 56.57. I had to round to two decimal places. So it's point, it was negative 56.568 or something like that. And so anyway, I rounded up two decimal places. Okay, so then once I have the components, add straight down the x column, add straight down the y column. So here are the components of the resultant. Yay, okay, that's not actually an answer that I need to enter, but I got to do all that work ahead of time. Once I have the resultant components, then I'm going to graph them. And the first way I graph this, let's just focus in on the part that is important here, is I redrew the whole graph, redrew a graph, and wanted to put just the resultant on here. So I did the x component, negative 56 across, and the y component was 693 and some change. And so my resultant shows as an x component and a y component. But here's the problem. If I draw this, I drew it this way because I've told you before, always draw the x component first and then the y component. And so I drew it this way. And then after I had it drawn, I realized, you know what? This angle that is inside the triangle right here is not actually the angle that I want to find out about, because the question says, what is the amount of degrees off course that the airplane is going to go? And the airplane is trying to go straight up on my graph. So this angle, I could totally find. I can set up a tangent ratio using the opposite side and the adjacent side. I can calculate this angle, but that's not the answer that I'm after, because that does not tell me anything about how this resultant compares to the direction that the pilot is trying to go, which is straight up. Okay, are there ways to do this mathematically? Yes, it's a right triangle. I know that the triangles can add up to 180. I could find this angle and subtract and do some stuff, but it's probably more direct and therefore simpler if I just redraw my vector triangle. So I'm going to go up first because that's the direction that the pilot in my story problem is trying to go. So up 693, across negative 56 degrees. And so now, starting from the origin, The 693 is going to be my adjacent side. Negative 56 is the opposite side. When I set up my tangent ratio, it's going to give me this inside the triangle angle, which is actually the answer of how far off course the pilot ends up. Trying to go straight up, gets blown off course. That's the angle that I'm trying to find. Okay, so I set up that tangent ratio with opposite and adjacent drawn like my right hand picture, and that gave me 4.66 degrees. I did ignore the negative. It's super sloppy negative sign, but the negative on the 56.57, I did not actually even type that into my calculator. If you do type that in, your calculator is going to give you a negative degree, and that is completely irrelevant for this problem because it does not ask for direction angle. It just says how far off course. Well, it doesn't matter which direction off course, it just says how far off course. So I'm going to enter my answer as positive regardless of what my illustration looked like, because that's what degrees off course is going to be. It's just the number of degrees. We don't care whether it's clockwise or counterclockwise. So 4.66 entered as a positive value. And then for magnitude, I took my two components, squared them at them, took the square root of that sum, and got 695.73. And that's my magnitude, and that is how I got 3 out of 3. See, it says I haven't changed since last time. It won't let me resubmit unless I change something, but I don't want to change it because it's already right. So I'm going to leave it.